Which one from yesterday? Question 2, Regents exam. What's it going to be when I separate them? All good? Okay, not a big deal. Look, that was an actual question. That's pretty nice, huh? Whether it's now or in a month from now. Go to number 11. Go to number 11. Yep. Observational study is I just go in and watch. I don't separate any groups. I don't do anything myself. I just go in and watch. All right. Okay, number 11. Yes, it's nice to know a little math going in, but it's also nice to know how to take a test. All right. Not only do you got to be strong Algebra 2 students going in, but also good test takers. Right? Specifically on the multiple choice. So for this one right here, as you guys read through it and the facts that are given, try for me right now to eliminate 2 of those answers. Give yourself a shot, 50-50 shot right now. Are you able to, based on the facts alone, are you able to eliminate 2 of those answers? Anybody confident they can eliminate 2 of them? Lauren, you can you? You can confidently eliminate 3 and 4. The question is why. Ready? Here are the 2 facts. Quadrant 4, I'm looking for tangent. All students take classes. What's the only thing positive in quadrant 4 according to that capital C? Cosine, not tangent. Okay? So now you're down to those 2 choices. What do you know about cosine? Anything. Throw anything out at me. What do you know about cosine other than it's positive in quadrant 4? Okay, perfect, perfect. It's adjacent over hypotenuse, and it's equal to 7 over 25. Everyone with me? What do you know about tangent other than it's positive in the third? Opposite over adjacent. Hey, guys, don't we already know the A value? What's the A value? Okay, we done? And I didn't even do it correctly at all. Like, I didn't even touch this bad boy, which I could have. All right, but for time's sake and for your sanity today, I'll avoid it to another time. Because if this comes up in a part 2, 3, 4 question. But everybody good how I narrowed it down to that choice and that choice only. Lauren eliminated 2 of them, and I eliminated the other one there. We good? Okay, speaking of part 2, let's go. 29, here we go, 29. These come up a bunch. Okay, solve for x. First thing I got to do direction-wise, so you don't short yourself points. Everyone see how that word algebraically is in there? That is a fancy way of the writers of this test to tell you you cannot guess and check. You will receive 0 points if you guess and check the correct answer. Okay, so when you see algebraically, no guess and check, you have to set up something and solve it. Okay, so maybe 4 would work, maybe 10 would work. It's not going to happen. All right. All right, let me throw it out to you guys. How are you going to get x? Value of x or values? Anything. They're all fractions, right? Try to get it set it equal to 0. Okay, here's the thing. What I have with setting equal to 0, you're going to move. The 1/2s aren't bad to move over, but then when you move over like this x minus 6, I don't know what you're going to do there. Okay, so you're throwing something out, Aiden. Good. All right, but I don't think that's going to work for us in this case. Anything else? Suggestions? All have the same denominator. That could be an option because I see different denominators. I always think a common denominator, right? Okay, I am going to do that. But everybody see how many fractions do I have on the left? And how many on the right? Make each side one fraction. And why do I say make it one fraction? Anybody know how you solve something, a fraction equal to a fraction here? Yeah, there you go. You guys know what to do if I give you a one fraction equal to another, so do it that way. So let's start on the right-hand side. I got 6 and 2 in the denominator. Common denominator? 6, perfect. 6 and 2, common denominator 6. So what should I put on the top now? Anything going to change here? Nope, perfect. You guys are good. You're good? What do I got to multiply 2 by? All right, so this on top will be x minus. Nice job. Made that into 1. Good. Now can we get the left side into 1? Ooh, a little different denominators. I got 2 and x plus 3. Nothing you can do. Because, hey, these are separated here. You can't do, oh, the 2 and the 3. It's not like that. It's just 2, put it together. X plus 3. That's it. Just put them together. And when in doubt, put them together. You're never wrong if you just put them together. You might have to do a little extra work at the end, but when in doubt, you can put them together. All right, what do I got to multiply that negative 3 by? Look, what's missing? What's missing here? 2. So that'll be negative 6. What's that 1 got to get multiplied by? X plus. Right? Question me now if you don't know why I'm multiplying by them. It's just what I got to multiply the denominator by. I got to multiply by the numerator by the same thing. So what's that going to be? Plus x plus 3. All right, can we clean this up a little? I got a lot of things working here. Clean that up for me. What's on top now? What's on top? Just combine your like terms, guys. X minus. And what's on the bottom? Nothing to clean up over here. And you guys said, how do you solve this now? Okay, go. There's some things I can't do all for you. There's some things I gotta let you go on your own. So go ahead, cross multiply, just set them equal. And then we'll talk where do I go from there. Just set them equal to each other. And yes, this is painful for me when we just stop and stare and don't do anything. This is painful. At least try something. Where'd that come from? Where'd that come from? Okay, but it's all of this. Okay, but but you still got to multiply by 2 then. You just multiplied these 2, right? And got that. I don't know where that came from. Okay, so you're multiplying, but this is one whole thing that has to get multiplied by that and separately. It's not this and this and then this and this. It's all of it times x minus 3. Problem some of you guys are having is you gotta have the 2x plus 6 here. You guys are trying to multiply 2 times x plus 3 times x minus 3, and you're like, oh boy, I'm done. All right, and you don't know what. Yeah, distribute. That's why I wrote 2x plus 6 here. That's why I wrote 2x plus 6. Okay, here we go, because we're trying to go ahead here and it's not looking pretty. 2x plus 6 times x minus 3. I'll write it out. With me, ready. Boom, what do you got?
X squared.
What do you got?
Negative 6x.
Negative 6x plus 6x. What happens? They're gone. 6 times negative 3. I'll tell you when I'm nervous, and I'm nervous if you can't do that. I'll be honest with you, all right? Through this whole process, I'm nervous if you can't multiply those two. All right, now some of you guys tried to go ahead, and you definitely want to use your eraser or cross it out, because I'm not too sure what you were doing. Everyone see this squared here? That's a signal to you. It is time to factor. When I see the squared, it is time to factor. And you cannot factor a darn thing unless it's equal to what? 0. Okay, it's equal to 0. So if I brought over, how am I bringing over the 6x? Subtract it. How do I bring over the 18? And what would happen when I brought over the 18? They're gone. So what's the only thing I'm left with now?
2x squared minus 6x.
We good here? Okay, how are you going to factor it? What can I do to factor this? Take out a 2x. When I take out a 2x, what's left? Okay, what's one possible value of x now? One possible value of x now. You've done as much as you can. One value of x. I don't know if you guys ever did this. Put the line down. X minus 3 equals 0. And on the other side, 2x equals 0. What's the x value over here? 3. And over here, divide both sides by 2. X equals 0. Anything else? Get ready for your number to be called. 30. Hasn't been too long. Hasn't been too long. Let's graph it. I need help setting up the x-axis first. We remember it's key values, but how I get there. So I can set up the x-axis. What do I need to start out by finding to get to, what do I break up into? Good, here we go, period. Formula for period, here we go. Now this is where the fun's gonna begin. Yep, 1, period formula. Okay, look at the equation, what's my b value? A, B, C, they're only numbers, no variables. 2. So what's the period, Aiden? Pi. That's not what I'm going by. To find the key value, I take the period and do what with it? Let's go. Here we go. 5 divided by 4. So I'm going to go every pi over 4 now. I'm going to count by pi over 4. Here we go. Pi over 4. How do I find the next one? I think I can spread it out. How do I find the next one here? 6. What's pi over 4? Next one? Perfect. 2 pi over 4. Next one. Yep, I'm doing it. 2. 3 pi over 4. Next one. 2 again. What were you going to originally say? 4 pi over 4. The 4s cancel out. Just pi. But hey, write 4 pi over 4. No one's going to be critical of you. All right? When do I stop this whole deal? Directions. When I hit 2 pi, we're not there yet. Keep trucking. 7, next one.
It's going to be 5 pi over 4.
Next one. 10. Oops, wrong one. Next. 1. Next one. 5. Done. There's your x-axis. What about the y-axis? What values do I need to find on the y-axis? Max and minimum. Here we go. I'll do the max first with somebody. Okay, here we go. Finding the max. Here we go. 12. What was my max before I did anything? 3, and then you did a shift of what? 2. What's your new max? There we go. Minimum. We remember this. 4. Before I did anything, what was my minimum? And then I added up 2. What's my new minimum? There you go, everybody. So make sure you have a -1 on there and a 5. 1, 2, 3, 4, 5. Okay, here we go. Sine curve. We're graphing sine. Where's sine usually start back in the day? Oh, 3. Where's sine usually start? Where? 0. But what happened here, Elena? Yeah, because I had the shift to 2. So it starts out not at 0, but at 2. It's also called my midline. All right, where's sine go from there? Starts at 0, goes to where next? 10. Max, what's my max? 5. I guess I didn't go by 2s, but then it goes where? 4. I got midline or 0. Max, then where? We're at the max. Go back to your 0, your midline, which our case is 2. And then next point, it goes to where? 5. Minimum. And then it returns or ends where? 13. Back at your 0. And then we repeat it one more time to get to 2 pi. Not bad, huh? Yep. Anything you want to ask there? All good? Okay, put that away. You got your stats packet. Quiz coming Tuesday. First 3 days of stats will be on there. Yesterday, today, and Monday. Before we start, I wasn't here yesterday, but I heard we did something cool on the calculator. Okay, I wasn't here yesterday. I need a little help. We have this table of numbers that I need to put into the calculator. How do I get to put them in there? Direct me. Stat. Yep, I got stat button. Number 1, edit. And then I type in my numbers. So let me do that real quick. Type in some random numbers. That happened 12 times. That happened 14. That happened 15. And that happened 3 times. All right. And then my paper's telling me I need to find the mean and the median now. So I got all my numbers in. Thanks for helping me with that. Where do I go from here now? Stat again. Calc.
Click on 1.
Okay, let's pretend that wasn't there. How do I get L2 in there? Because that's where my frequency is. Second 2, boom. Calculate. Ooh, that's a lot of numbers. I have no idea what everything means. Where's your average, your mean? Top number, X bar, yep. I do not see median anywhere on here. Oh, I got to scroll down. Okay, got it. There's the median. Got it. Okay, all good. And then the calculator does not give you the mode. What would be my mode here? 8. Why? Occurs the most 15 times. Okay, everyone ready to go now. New, you might want to hurry up, boss. Some new values on the same screen. Okay, new values on the same screen. First value I'll talk about is the range. You guys, I think that's something you have heard about before. Range. Highest minus lowest, okay? No big deal. Highest minus lowest. So in this case here, these scores I give you, 4. What's my high and my low here that I can subtract? 68, yep. So that is a range of 30. Okay. I also have something called the interquartile range. Interquartile range. Maybe from your Algebra 1 days you did this. A set of scores can be broken up into 4 parts. Okay, you got your minimum, and I'm just putting lines here. You got your minimum, you got your first quartile, you got your middle, which is also known as what for us? The middle. Median, and then you have the third quartile, and then the max. Everyone see, I can break it up into 1, 2, 3, 4 different pieces. The difference between the third and the first quartile is called your interquartile range. Okay, this one in particular, help me find it now. First thing is, I got to help me break it up into 4s. First, find the middle. What's the median here? What is the median of these scores? We did this yesterday, so what number is considered the median here? The median, the middle number of all these. Here you go, 8, middle number of all these. 86 is my median. Okay, there's the median. Quartile 1 will be the median of the lower half. Okay, quartile 1, whatever number is represented by quartile 1, that's the median of the lower half. So now take your 51 to 86, find the median of that now. What's the middle of your lower half now? 4, when you find it. I'm looking for the middle number of the lower half now. That's quartile, that'll be quartile 1. I think it is. Here you go, 51, 86, 75, 84, boom, boom. So it is, yeah. So that'll be what? 79. Everybody good? And what about the upper half up here? What do we end up with here? 91.5. So the interquartile range, 91.5 minus 79. End up with 12.5 is your interquartile. I abbreviated IQR, interquartile range. Also, I just want to let you know your calculator can do this. I just wanted to say it was quicker doing it this way. If you see on your calculator, if you keep scrolling down, what values does your calculator also give you? Q3 and Q1. Okay, I just didn't want to waste. You could put all these in a list and then get that screen back up. Okay, everyone good there? If you're really unsure, you can always plug it into your calculator. So I got range, interquartile. Here's the big dog for today, the most important one, which is standard deviation. Okay, can you guys do me a favor? Can you get your, I don't care what's on, what numbers are there now, but can you please bring up your one bar stat screen for me? I don't know if you cleared out everything or, yeah, put a couple, put 3 in each side and do it. I just need a 1 bar stat screen up for me. Okay, on your 1 var stat screen, there are 2 standard deviations. Does everyone see OX on their stat screen? OX, everyone sees it? We're good? And then there's a sample one, which is SX. Everyone see that one? Okay, so there's 2. I will need you to know what they're called. So the sample is SX, population is OX. There, I call it the OX for population standard deviation. OX looks like the word OX. Okay, good. If a problem does not specify which one it wants, we use population. Okay, use population if the problem does not specify. Okay. What is this number telling us? Because this is the big part of today. What is this number telling us? The smaller the standard deviation, I'm just going to abbreviate it SD, the smaller the standard deviation, the more consistent the scores. I'm going to ask you what I mean by that. Okay, the smaller that number is, the more, what do I mean by consistent? So keep going. Keep building on that. Okay, ready? Your probability, and this is not true, your probability test scores were pretty consistent. What's that mean? Basically, everyone was right around each other. Versus if I said your probability test scores were pretty spread out. Yeah, we had a wide range. So everyone okay what I mean by consistent? They resemble each other, all right? They're close to each other. And I tell you that because of this next question here. I got test scores A and test scores B. They both have the same mean. Which one's going to have the lower standard deviation without plugging it into your calculator and finding the actual values? Just based on the scores alone, can you predict which one's going to have the lower standard deviation? Remember what it means to have remember what the standard deviation means. It shows me how consistent scores are. So out of A and B, which one do you think will have the lower standard deviation or the smaller one? 9, prediction?
B.
Why? You're correct. They're more consistent than A.
Yeah.
Right? Everyone agrees? Everyone see what I mean by consistent? Right? They're more consistent than the scores in A are. So set B because scores are more consistent. Okay, I want you guys to have practice calculating them now. So Miller and Lopez family. Find the mean and the standard deviation for both families. All right, let's do, I'm going to have somebody do the mean for the Millers now. So let's do the Miller family. They got 3 kids, 10, 12, and 14. What was the symbol we used for mean yesterday? X bar, right? Okay, I don't think you guys need to plug that into your calculator, right? You can find the mean right now. Mean is it 12?
Yeah.
Median's 12, but mean is 12, all right. How do I get standard deviation? How do I find it? That's in the calculator, correct? Okay, so ready? Where am I going to put 10, 12, 14? Stat, edit. 10, 12, 14. Don't need that 9. All good. because I'm doing this on purpose with you. So now what screen do I go to? Where do I go from here? It doesn't matter that something's in L2. Go to stat. Where? Calculate. One var stats, right? But hey, what's going to be the change up here? Yeah, there's only one list, and that's the Miller ages. So get rid of the frequency list. I don't want the calculator to look there. I just only want it solely to look at list 1. And calculate. And does it specify which sample standard deviation I need? Nope. So we look at the population. The population, which is which one up here? OX, right? The ox. All right. Always population we look at. So that's about, I'm going to go nearest hundredth, 1.63. So 1.63.
Standard deviation only goes from -1 to 1.
No. Nope. Nope. You're thinking about this normal curve, right? All right, can you guys go do it for the Lopez's now? We can do the mean real quick. The mean is average age of the Lopez kid, 10. And then go ahead and build a new list. And let's see what their standard deviation is. Nearest hundredth. Five. When you get it, let me know. Standard deviation for the Lopez family. Yes. 3.67. Okay. Give me a conclusion about their ages based on those two numbers. Give me a conclusion about them, about their ages, just by knowing those two numbers. 1.63 and 3.67, their standard deviations. What's that tell me? Ages of the Lopez are more spread out, or on the flip side, we could say, what about the Millers? More ages are closer together, yes. So whatever you want to write here. All right, so Miller kids, Miller children are closer in age. Why? Because they had the smaller standard deviation. Questions? All right, we're going to finish this off with fireworks now. 30 students in Algebra 2 class. There's their grades and how many of them occurred. Right, we went over this yesterday. How many 65s were in the class? Solid. How many 88s? 3. Okay, so we know how to read it. First thing I'm asking, determine the 5-number summary. Whew. Anybody dig back to their Algebra 1 days? This is what you guys remember making. We're not going to do this at all in this whole entire unit. Making those box and whiskers. You needed a 5-number summary to make the box and whiskers. The 5-number summary was the minimum. Yep, hold on. Q1, median, Q2, and max. Yep, those are the 5 values you need to make the old box and whisker. I would highly discourage you from doing this by hand, unless you want to write out 965s, 374s, and doing it that way. We can get these simply from the calculator. So where are you going to put all the grades and the frequencies? Lists. Yep. Go to your list, clear them out, put in the new ones. Please be careful when you type them in. Honestly, I don't care. I do need an L2. Calculator's nice. It conveniently gives you your 5-number summary all in one bunch. That is great. There it is. There's your 5-number summary, everybody. Looks good. Remind me, beginning of class, how do we find interquartile range here? Interquartile. Oh, yeah, 7. How do we find interquartile? Yep. So 88 minus 65. Let me know what you get there, big boss. We do have 23. Yep, here we go. Mean, X bar to the nearest 10th, all on your calculator. 7 again, yeah. Yeah, we typed in something. Or forgot something.
We must have typed in something wrong. I don't think it's calculating for my list 2 also, because I don't get the screen before when I click one more step, it just goes straight to here.
Okay, is that your calculator?
Yeah, this is
Okay, so you need to stop by for like 2 minutes one day so I can update it. You know how your phone has an operating system which needs to be updated?
Yep.
Same thing here.
Okay.
It just needs to be, your calculator's fine, just needs to be updated.
All right.
So for now, if you get to that point, you do L1, comma, L2.
Okay.
All right? If anybody else has that issue, just need to update the operating system. 79.5? Okay, here we go. What about the population standard deviation in the nearest 10th? 11 point. Oh boy. 7? 8 rounds it to a 7. All right, here we go. This is going to be a little something new we're going to end on here. A couple we're going to end on. What number of scores fall within 1 standard deviation of the mean? Okay, what does that mean? All right. What's the mean? 79.5, right? Okay. If I told you I'm within 1 pound of my target weight, and my target weight is 190 pounds, where do you think? How much do you think I weigh right now? If I'm within 1 pound, within 1 pound of my target weight, or I could be 191, or okay. So if I want to be within 1 standard deviation, what was the standard deviation? 11.7. So if I'm at the mean, I'm going to go this way, 11.7. Let me know what that new score is right now. What's that score there? 91.2. Or subtract 11.7, which was the standard deviation. And where do you end up now? All right, so I need to know how many scores fall within this range. Because this is right here. Take a look. This is within 1 standard deviation right now. 67.8 to 91.2. Go back to your table. Which scores can I count? Which scores can I not count? 65 counting. 74.
No. Yeah.
79. 85. 88. 94. Okay, I'm not going to ask more. Watch your mouth now. Watch your mouth. How many scores fall between here? Because automatically I get a kid chirp up. 4! That's how many circles. But that's not how many times they occurred. There are 15 scores here. All right, let's keep trucking here. Probability that I pick a score that falls within 1. Probability. Well, how many scores fall within 1? What did we just find out? 15, but probability is out of something. The total, good. 15 out of how many scores? You can read the directions at the top. They say 30. You can add them all up. You'll still get 30. Or, ready? I don't know if you still have this up or not. N value is the number of scores you typed in, okay, on your calculator. Good so far? Oh, yeah, plenty of time here. Plenty of time. What do I got? Oh, yeah, we got it. Yep. Percent of scores that fall more than 1 above the mean. Not within 1. More than 1. So what am I looking at now? More than 1. Anything above? 91.2. More than 1. So it's going to be how many? 6 out of 30.
Oh my God. What a perfect way to end my weekend. Wow. Oh,
Great.
Good weekend. Good man.
Maybe a little practice too would be great.